Wrong. Gonna be Mr. Samuels instead. Sorry. Put your phones away, get those earbuds out, and put those lattes away. Those Lockport lattes that you guys drink. Spend $7 on. Let's do some math. Did you guys do the first ones? Huh? Did you? All right. Here we go. Where's my pen? All right. Let me get my fat head up in the corner here. And let me show the screen so that we know we're live in Mr. Samuels's class. Okay, what'd you get for the first one? 3, 2, 1, go. 7. This is so easy. 2 times 5. If you get your calculator out, you make me sad. All right. And the next one. This one is weird. 2 what? It's not CX, right? You don't multiply those two. That's not what's happening. You know what this is? This is flat out, starts with an S, SU, SUB, substitution. You just said an S word. This is flat out substitution. By the way, introduce this section. I know this comes out of left field. It feels like that happens a lot, like yesterday's lesson. But yesterday's didn't really come out of left field. That we were doing regressions, unless yesterday's lesson was about, how far the regressions could diverge from the actual coordinates, and that's one way of seeing if your function is good. And we've been doing regressions for a while. So, but then where does this come from? We've done a lot of different functions now. Now we're going to do an algebra situation with the functions we've dealt with. So this is always kind of where this is inserted. So this isn't an AP random thing. In our green book, after we do a family of functions, graph them and manipulate them, shift them like we've been doing with stuff, then all of a sudden we do algebra with functions. And what this is called is composition. All right, next one, just to slow it down a little bit, you substitute a 4a in for x, and then you have to do a little bit of algebra, right? Just want to make sure I don't remember this answer from last hour. 8a minus 3, we good here? Then the last one, I don't understand this, but if you get this, this is the hardest part of this section. Where students get crazy is when what I'm substituting into the other function has the same variable. This is just like a place marker, right? And that's all that it really is. So what you should have righted, I don't know what the right version of that word is. Wrote, what you should have written. Okay, English and math. All right, got someone shaking her head. Yes, we'll assume she's an English expert. What you should have written is this. The x leaves, and actually it's funny, someone in first hour at the very, very, very end of our notes treated this composition of functions as a multiplication, and it's not. All right? It's a flat out substitution. I don't care if the letters are the same. I don't know what else to say about this. This is what has to happen. If you get this, then the most complicated stuff we're going to have later will not be complicated at all. How many people got 10x minus 5? Raise your hand with pride. All right. All right. You didn't raise your hand over there. You did get it right. You're just too lazy to raise your hand. Got it. All right. Next. Here's what composition of functions are. Mr. Bean's much nicer. All right. There are 2 ways you can write a composition of functions. All right. The one way, and this is important for you to know if I ask you this on a test, hey, find this. You have to know that that means compose these 2 functions. All right, and this is our new concept for the day. But anyone in Math 3 last year, you should be fine. I don't know about Math 2. I know in Math 2 honors we do. I think we do. Now I'm trying to think if we do. Yeah, we do. We definitely do in Math 2 honors composition of functions. I don't know about regular. This might be a new thing. It's really not that bad. Here is the better way to write it. I will say, because this actually tells me how to actually work with this. And what you do, that's the next part, jumping ahead of myself. Let's say in words what this means. So, and I quote, both of these are read F of G of X. I haven't written in cursive in a long time. Right? Felt good. F of G of X. I want to write in cursive, so the F is different from my word of. And that's how I read it. All right. Always, I'll give you a 50-50 second hour. You guys okay over here? All right. How do you work with multiple parentheses? Is it inside out or outside in? 3, 2, 1, go. Inside out. Inside out. Unfortunately, the closest student to me said outside in. Don't listen to them. All right. When working with, they were just messing with each other too. That's what I just yelled at. When working with composite functions, we start on the inside. Are you okay? He looks upset now. Or to the right. So if you look at f of g of x, you start with g of x, right or inside, whatever. Given f of g of x, so just like we have up here, evaluate g of x first. That's how our first construction of these are going to go. But then right away, they get into composing two functions without a number. So that's going to be a different thing. But anyway, in the first iteration of these, then use that answer from g of x to insert into f of x or plug in. I'm going to show you how that works out right here. First ones are really easy. First three. I feel like there's too many examples here. But I guess I'll go through them all. I don't know. It seemed fine last hour because some weird answers happened on the next one. But this is what I mean. So you start on this one. I could zoom in a little bit and then shuffle over to that other one. And I'm going to do A, B, C first because D and E are way different. All right. So it's simple. You go on the inside, and this is a bell work. Simple question. It just means I go to the G function. That's this one, and plug in 3 for that. And I think you can do that in your head. Unfortunately, people in first hour are calculating that with their calculator. What's 2 times 3 plus 1, everyone? 3, 2, 1, go. 7. He's back in business. All right. And then what's f of 7? That's a simple separate question now. I plug in 7 now into that other function. Very simple. 3 times 7 is 21. What's 21 minus 5? 16. And then you move on. So f of g of f of numbers, very simple. All right. Next one. At this point, I could probably turn off the video and say, do these yourself and get an answer. But let's all group response like the olden days, like in the 90s. What's f of 3 now? What do we get, class? 3, 2, 1, go. 4. I do have some people. Hey, second hour showing up. And then g of 4 is what? 3, 2, 1, go. 9. There they are. It's easy stuff. 4 times 2 is 8 plus 1 is 9. I'm not writing that out in a high level senior and junior honors pre-calc AB class. Anyway, f of. All right, so what does that mean? Well, don't overdo it. Just do f of 4. What's f of 4, everyone? 7. Okay, 4 times 3 is 12. 12 minus 5. And then what's f of 7, which is weirdly enough what? Oh, I already had f of 7 over here, which is what? 16. Now it's going to get different. So I do want to zoom in on these and look at these next two. Notice one says f of g of x. The other one says g of f of x, a reversal. One common thing is people reverse these. I don't know why. There's no reason for it. Cover this up, work inside out, and then you should be fine. But this one doesn't have a number. So now these are what I would consider algebra questions. Your answer at the end will be in terms of x because I don't have a number there. So since I don't have a number, I can't evaluate g of x. So what this means is I'm literally inserting one function into the other, which is also called anyone saw? You got it, not subtraction, substitution. All right, so f of, what is g of x? Well, g of x is all of this now. So that's what I have to insert in these parentheses here. And now we're at the bell work, my silly little friends, because that is exactly like this question. What was f of 5x minus 1? Replace that x with a 5x minus 1 and then simplify. That's what I said the hardest part of this lesson is. And it is not hard, actually. All right. Mr. Bean never says that. All right. So, all right. F of that becomes 3 times 2x plus 1. And I know in the other hour I did highlighting. So f of x, wherever there's an x, I'm replacing it with this. That's why we see this. Look. All right. Not too bad. And I think you can hold a couple things in your head. 6x, 3 minus 5, negative 2. So this is 6x minus 2. Do not factor. Do not set this equal to 0. I'm just talking about silly things that I see my students do. That is it. You simplify these, all right, when it's not in terms of a variable. I do see some people, they got it, so they're kind of working on their homework or whatever, moving ahead of me. Make sure you pay attention to the bottom one, and then the very end is a little bit, it requires imagination. All right, I'm not using highlighter anymore because I already highlighted the first part, so you get it. This is g of switching it. Now f of x is being inserted into g of x. That's the way to look at this. All right, so g of 3x minus 5. I guess I could highlight this though. Wherever there's an x now, I'm putting 3x minus 5 in its place in the g function. So substitution really is. It's really what it is. All right, and then this is 6x, negative 10 plus 1 is negative 9. So I have 6x minus 9. Great. These are unique questions. This is weird. So we have f of x described by a graph. And actually, that graph does represent a piecewise function. Oddly enough, h of x is a piecewise function. We had a big section on that. We never really made you graph it, which is unfortunate. I think we should have done that, but the AP steered us away from that. And then a g of x is a chart. Input, by the way, all of these are input outputs. One, I have the outputs. Another one, I have the outputs in graph form. Another one, I have the equations for a piecewise function that I have to create the outputs. Okay, so I like this though. It's different. I've never seen a question worded like this before. It just directs you where you go. So I kind of have to say cryptically out because I have to see all three functions and then do this first one. So what's g of 5? Well, here's the g function. Input, say it. When I input 5, what do I get for an output? 3, 2, 1, go. Negative 2. So it's a really good practice about how functions can be listed. This is why I've said input output since the beginning of the year. It can literally save you on so many things. I know specifically, giving you a clue, being the test writer, at least one of the main ones. One of the questions requires you do some sort of math in order to rewrite an equation. But literally, input, say it, can save you. And actually, it can really save you in a lot of different things if you really understand that. Okay, and then now f of negative 2 means I have to go over here. What's f of negative 2? Input, say it. 3, 2, 1, go. 4. Or, sorry, it's not 4. 3, 2, 1, go. 2. I don't know why I said 4. I don't know where that came in my brain, the 4 number. Input, output. Understanding that a graph is a series of input outputs. Ain't no thing. Anyone? Chicken wing, good. I feel like I have not said that a lot this year. Not many people know that saying. Do you know that? No? Never heard that? How did you know? That's from last year? Or did he say it? Anyway. Remember, h of f of 8 can be written like this and just tells you where I go first. What's f of, I don't remember doing this one. What's f of 8 last hour? What's f of 8? 3, 2, 1, go. All right, wow. He yelled it fast. So then h of negative 1. Oh, no. All right, now I have to go to the h function. Which one do I plug in negative 1? First, second, or third part of this piecewise function? 3, 2, 1, go. First, because h, the input's negative 1. Negative 1 is this input structure. That's how a piecewise works. Sorry, I can't get my words going here. So I input in the top one because that's where x is less than 1 and negative 1 is less than 1. All right, so then this becomes negative 7. Fine, I'll write this one. 3 times negative 1. Negative 7 plus negative 3 is negative 10, but what's the absolute value of negative 10? 10 is the final output of these two inputs. This is weird. I almost stopped in the other hour. I'm like, isn't this enough? But then this next one's strange. What's g of 0? That was supposed to be an eraser. What's g of 0? Do you see 0 on the chart? No. And I don't think they want you to be doing a regression and come up with an equation so then I could input 0. I don't think that's what we really want to be doing on this. So in this kind of question, we just say DNE. All right. This could be a discrete function. I don't know. There's not enough information. Usually they're not. But I'm just going on. That's not what you want to be doing in in a composition of functions. If it doesn't exist, move on. I think this happens again. F of, all right, we had that up above. Don't worry about it. Just do f of 2 first. Input. Ooh, this is interesting. F of 2 is what? 3, 2, 1, go. What is the answer? What's f of 2? 1. That's the whole point of a piecewise function. There's a jumping off point from one part to another. But it's colored in there, so it's 1. And then this does exist. What's f of 1? 4. Okay, 1 graphs to 4 up here. So understanding a graph is a series of input outputs, which I really don't think. That's why I'm big on that in all my classes. I really don't think when people walk into a math class they know enough about graphing and knowing the input output factors, and that's good. All right, h of 1. Where does that go? First, second, or third part of this function? Second. What is h of 1? So g of, here we go again. Now I have to go to the, oh no, that's fine. I have to go to the g function. What's the output for that? 3, 2, 1, go. Pi. Just a weird number to throw in there. All right. So we got that going on. Maybe it's the last one that has a problem. Okay, what's h of 5? What's h of 5? 3, 2, 1, go. Negative 5, right? Oh, sorry. H of 5 is, oh yeah, negative 5. Now, where input output for f of negative 5, what do you get? 3, 2, 1, go. DNE. This function has a domain of -4 to 5, not including 5. That's enough. There is no -5 existing for this graph. So f of -5 does not exist. Or maybe you could put 0 with a slash through it. There is no answer for it. Null set, a 0 with a slash through it, I believe would be mathematically technically good. Oh, how many people are tired? All right, why don't you go ahead and do those 3, and then I'll pause our screen in here. Those on the video, you'll see me doing these, pausing their screen. You check yourself before you wreck yourself. I don't say that either anymore. Oh, I'm losing my touch. You guys online. This first one, you go here. That becomes, I don't want to say it out loud. You got someone hawking me over here trying to steal my answers. And then you do this. I made a mistake first hour. I plugged it into the wrong function. I didn't go to K. Oh, I love math. All right. And then some goofball last hour, we won't say her name, just typed -3 squared on her calculator and got -9. That's wrong. It's 9. And then P of 0. Ooh, okay. So that's 1. And then when I plug in 1, come on, that's pretty easy. 3 over 1 plus 1, 3 halves. They might want you to save this because we're going to have domain issues on these next 3, but we're in pre-calculus. Square root of, so not real, but we're going to go ahead and square root of -2 is. Okay, you guys ready? I whispered to the people, probably put them to sleep. But here we go. Yoink. Did you get IRA 2 for the last one? Did anyone go that far? All right. So I think they might want you to say not real for that, because the next parts we have to actually talk about the domain. And I probably should have done it on the previous ones when we have to do algebra. All right. But anyway, K of or M of -2, you go to M, -2 plus 1 on the bottom is -1. 3 over -1 is -3. Then you input -3 into the K function, which is that squared function. One thing to note, I did whisper into the thing, sorry, this first hour student. They go, I didn't get that, and I knew what their mistake was. They're a calculator drone. They can't evaluate without being, typing in, and they literally type this -3 squared. The calculator will spit out -9. What's a -3 times a -3? 9. Okay, so we should never be typing that in the calculator. We should be thinking. I think when we type on our calculator, we don't even think about the numbers. We just let the calculator do all the work. That's why input, say it, has been a disaster. When I ask you to input output to make coordinates to make a graph, and we take your calculator away on a test. I like Mr. Bean better. He never yells at me. All right. So now we're to this one, and I stopped this on purpose because now we got some algebra going on, and you're going to get yelled at again, or at least told what's going to happen to you when we grade, and we are the teachers. So now we don't have numbers. Anytime we don't have numbers, it's algebra. So we are inserting one function into another. So the very first thing you do on this is k of whatever h of x is equal to, which is 2x minus 3. And this first one I'm going to highlight one last time because it's the only thing that we could run into troubles. Then when I'm done with all three of these, I'll come back and talk about the domain. Sorry, I'm trying to find k. So k of x, wherever there's an x, here's mistake number 1, not plugging in 2x minus 3 for all x positions. We haven't done algebra in so long in this AP curriculum. So long. Kind of feel weird about that. Finally, we got an algebra skill being brushed up. Here's where you're going to get like 2 points off. How do you square a binomial? It starts with an F. Careful, it's a 4-letter word. FOIL. FOIL. Foiling, good factors, good foilers. When's the last time we said that? All right. Just now, it's been like months, I feel like. I don't know why. So maybe one way you could do this is cross off the squared and write it next to each other and then do the lines. So I know we weren't so great maybe on this when we did chapter PR. Our algebra skills were pretty rough in some avenues. 2x times -3 is -6, and then another -6x. I should have said x. And then -3 times -3 is 9. Put that calculator away. 4 times 2 is 8x. Just talked about the calculator destroying math brains, just like the phones destroying brains. Don't get me started. The earbuds constantly stuck in the ear. Oh, teaching in America. 2x, the ear pods. Is that what they're called? -3 plus. All right. 2. All right. Now you don't factor. I don't care that has a greatest factor of 2. No, you simplify and write it as a descending in descending order. What's that called? I can't even think what that's called. My brain's gone. No. Simplified form, descending order. Huh? We added like terms. This is awkward. It'll come to me. All right, k of p of x. K of p of x. This one's weird, and I'm not going to write. Okay, fine, I will. So k open dot p of x is k of p of x. We're almost done, so just stick with me. All right. P of x is weird. It's the square root of 3x plus 1. I just told you I'm going to do the domain after I do all three. So I haven't talked about what is the domain issues, and then that's some review from the past. Okay, now k is this squared function up here. So replace x with 3x plus 1 squared. But then it also goes here, and then I'll zoom in on this. And then plus 5. Now, what's the matter? What's wrong? What's wrong? What did I do wrong on the last one? Huh? Oh, wait, -6x. That's I literally said -12x. Oh, I love when there's mistakes on the video. All right. Cool. Thank you. That's -4x. Mr. Bean never makes mistakes. All right. All right. Now, good call. Wasn't that right? Is that right? Did you guys make the change? Did you have that originally and I screwed up? All right. Just wanted to make sure. All right, now what happens with the square root squared? Shh. What happens with the square root squared? They can't cancel. Freedom. But you know what? There's nothing you can do with this. Don't you dare distribute that 4. It is not in the radical, nor should it be now. All right. So what's the only thing you could do? Add the 5 and the 1, I guess. And then leave this as a 4 root 3x plus 1. There's nothing to be done. Told you at the end we're going to do the domain. I'll do that in a different color too, unlike last hour, probably. And then the last one, m of h of x. Well, h of x is that 2x minus 3 cut off all the way to the left. So it's m of 2x minus 3. You had to look at it one more time. And then you go to the m function. We'll highlight this one since I haven't highlighted this at all. And plug in 2x minus 3 for that. And my short-term memory, I better leave this here for a little bit. 3 over 2x minus 3 plus 1. I know, not exciting. Again, do you math readers remember this? Yes? Okay, so it's really not that hard. A lot of stuff completely repetitive. I'm going to be honest, I feel like sometimes the algebra is a little bit light. Hopefully they keep it that way on the AP exam. A lot of writing and a lot of just terms to know and stuff. Kind of tough. And then no, you don't have to take out a 2. Just leave it. Okay, 3 over 2x minus 2. Now let's do the domain issues. Okay, well, to do the domain issues, we need to do the domain issues of the original. This is just a line. So what's the domain of any line except a vertical one? 3, 2, 1, go. All real numbers. That's true. A vertical line has only one domain number because it's a vertical line. Only has one x value. What's the domain of a parabola always? That's what x squared is. Huh? What's the domain of a parabola? All real numbers. Okay, this is why we're doing these functions. We've already done parabolas. We've already done square roots. We've already done rational functions. Kind of funny, we didn't show any exponentials in this little composition of functions. Should have had that, but oh no. What's the domain of this? Okay, this is why I was like a little leery on how to answer this question. What do they want? Do they want us to evaluate the I number? The problem is an I number doesn't graph. So we often think about when we have functions, what does the graph look like? The graph doesn't exist for this point over here. I can't evaluate it. I can't get it as an I number. So I guess that's the way we have to think. So the domain is the only parts that actually graph. So I numbers don't. So I can never take the square root of starts with an N. 3, 2, 1, go. Negative. So what makes this negative? Well, it's actually evaluating this. Set it equal to 0, and then this is the threshold of what makes this okay. Subtract 1, divide by 3, and you get negative 1/3. What happens when I plug in negative 1/3? This becomes what then? It starts with a Z, everyone. 0. I cannot plug in anything less than that. I plug in anything less than that, I get a negative. So the domain, this is review, is negative 1/3 to, infinity. I did have 0 in my mind. I have no idea why. You can plug in 0, 1, 2, 3. You can see those evaluations become positive and you square root positive and you're all good. All right, keep that in mind because then we have to go down to our functions that we created through a composition and talk about their domains. Then this domain we cannot divide by, starts with the Z. It would make me sad if you don't get this quick because we spent months on this. I felt like. You can't divide by what? 0. We talked about that forever. We had rational functions for like a month. I felt the way we talked about them and broke them down and everything. So what x value cannot be the domain then? 3, 2, 1, go. Nobody? Negative 1. If I plugged in negative 1, I would have 0 in the denominator. Here's what's weird about a composition of functions. Is she okay back there? All right. But her neck was broken. Her head was going like this. The domain issues are not only the original, they're also after you do the composition of functions. So remember I said that. First of all, Any domain issues with 2x minus 3 and the quadratic? Yes or no? No. And then any domain issues with our answer at the end here? Yes or no? No. So what's the domain of this new function and the originals? All reals. Ruh-roh, we got a problem. What was the domain issue for this that I was plugging in here? It just happened. I love you. Okay. I just love this computer program. There was a. All right, it just happened again. I can't stand it. Oh my gosh. Okay, let's move this. Mr. Bean doesn't do that. All right. The domain issue to begin with is I have to be greater than negative 1/3, including that. Okay, now let's try this again. I love you, OneNotes. Oh, I got to go all the way over here. Otherwise, oh. So look, in our new answer, we have the same component. So we have the same domain issue in the new one. So the domain of this is the same domain issue that's we started with. This has to be for only x values from negative 1/3 to infinity. This happens every day. I am so frustrated with this program. Anyway, then this is where you want to get nuts. Say it. Let's get nuts. Only one student said it. I think they're a little scared of the teacher yelling at the computer. Okay, now we had an original domain issue for this function here. So this carries over into my new function as well. So x still, even though it doesn't show itself up in this final answer, cannot equal -1 because that was carried over from an original. But we got another problem. What else can't x equal? What can I plug in for x in this new function? I get 0 in the denominator. Everyone say the number. 3, 2, 1, go. 1. So originally, because it came from a function that had a domain issue, you still have this domain issue. That's the thing I want to stop and make you think about. All right. So original domain issues, even though it doesn't show up in the new, and the new domain issue. Right. And that's all I have to make a big point out of. I don't have to overdo it any more than that. So that's one thing that's probably the one big star, the big thing, big idea that you need to lock in that could be a troublesome. All right. Then I want to speed this up and don't want to yell at the computer anymore. These are reversal of fortune. These are reversal ideas. So notice what it says in the directions. F and G are functions. F of g of x equals h of x. So this means this came from, let me go back to red, some f of g composition. So what you need to do is name what could those two functions be. I'm going to be perfectly honest with you. There literally could be an infinite amount of answers for this, but usually people pick the easiest. I'm going to actually give you two possibilities, but I want someone in here to figure this out. So I'm going to wait awkwardly on the movie. I could stop it, I guess, but I don't want to go through that. They don't have any ideas. So what we're saying is I have to plug one function into the other, and then h of x is the result. What could those possibly be? Now, don't worry if you're wrong, but I know I'll like your answer if you're right. And you do have to start with f of x, right? Because I'm sorry, you have to start with g of x because that's being plugged into f of x. So I think I might have reversed this in first hour. All right, go ahead. What's g of x? G of x. This is f of g of x. So you got it reversed, and I think I didn't get that right last hour. Go ahead. 2x plus 3 is g of x, right? It says f of g of x. So I'm plugging g into f. So he said 2x plus 3. Now I'm going to make someone else answer it. I'm going to be honest. He already said the answer, though. So what's f of x then? I think I reversed this last hour. Darn it. What'd you say? It's x to the 4th. So now if I did f of g of x, the first thing I would do is f of 2x plus 3. And then I got to make a correction last hour. I know I did this in reverse. Mr. Bean never would have done that. Would you stop saying that? And then it would be 2x plus 3 raised to the 4. How's that gum over there? Good? Next one. Wait, I said I was going to do another one. Or can someone think of another one? How about I do this? What if I said just g of x was 2x? Then tell me what f of x would have to be. Someone's got to be able to come up with this. What would f of x be then? Yes. Oh, yeah. Hand up, down. Yep. Nice. Then it could be x plus 3 to the fourth. And this is what I mean about there could be an infinite. And the more answers we get more and more complicated, you get really complicated, you could actually come up with an infinite amount of possibilities. One thing you cannot do, you can't be a bum and say g of x is 2x plus 3 raised to the fourth, and f of x is just x. Anyone understand what I'm saying there? So you can't do this. Hey, g of x is this whole thing, 2x plus 3 raised to the fourth, and then f of x is just x. And then this whole thing just gets inserted in there. You understand what I'm saying? This is not allowed. Got to have some little imagination, something that's a little different. Okay, last one. Let's get someone else to play. I can't believe I screwed up the other hour. No one said a word. They just accepted my bad math. Come on, somebody speak. I think we got the ball rolling now. This is all I'm getting in second hour. Nothing. I know they know the answer. We're just going to sit here awkwardly. And after the last one, nobody knows. Can you just help us out? I said he couldn't answer, but this is awkward. Go ahead. It's g of x first, right? Okay. I'm going to listen to you and see if this works. I don't think it will. Then what are you going to tell me f of x is? And you're okay. I'm glad you're trying, huh? X squared. That doesn't work because you know what would happen? I turn around and test this out. So I would have to do f of square root of 1 minus x. And then what I would have to do is plug it into this, which is squaring it. Then the answer would be 1 minus x. And that doesn't come up with the beginning. And I think you kind of did a reversal again, what I did last hour. All right. Anyone else? Come on. I can't pause the video. Go ahead. Wait. Oh, you moved your hand. Wait. You guys are all, you're going like this. Then, yes. So it'd start with g of x. I think you guys are reversing this. You have to plug g of x into f of x. So I'm going to stop you as soon as you say square root of. Nice. Nice. I got my eraser going. 1 minus x squared. And then what's the top one have to be then? Oh, you just blew my mind. He just said x to the 1/2, which is the same thing as what, everyone? Square root of x. That was amazing that you said that, though. But I'm going to write it as square root of x so we don't confuse anyone. That was awesome. I love that you said x to the 1/2, which is the same thing as square root of x. All right, got it? Because this is then inserted into that. That's why we got to go in reverse. So really, the first one you shouldn't be saying square root. Okay, and that's just one answer, and that's where we'll leave it. All right, I'm done. I spent a lot of time with second hour.